Okay. Everything is going there. Okay. So, has everybody attempted to code out what we kind of rotate eyes? So you theoretically now, it can be the actual code itself. So you have your white circle shift barrel shifter, correct? Right. I actually also think about a left shift one too, because so there is because I somehow upload that was the old one. I'll have to upload a new one. But all I'm asking you to do this time is just a shift. So last time I had people go through building like the individual layers and then jump to generate. I think that didn't help. So we just jumped right to generate. So I made people write down all the steps, but that's not what we did here. So, um, but I've got like 10 versions of these things, just updates new each time. And I uploaded last class as well. So I will attempt to get that fixed. But what you have to do is talk about the left shift circle. I need to see the code for it. All the basic explanation of how this works. You know, like we drew a picture. You know, what was the design? How did I get the equation? Things of that sort. I want you to do. I imagine you were starting from ground zero and helping somebody else walk the shift using Jeopardy. So it's basically everything we did just. So this will just make sure you understand. As a note, if you do look, has everybody used LaTeX before? Some yes, some no, some strong yeses. I really strongly suggest you use LaTeX. So maybe before we get into this, I'll um, walk a little bit into LaTeX stuff. I think that was the default. Okay, and I got to use choice of duo again. Uh, so this is the one I was mentioning is unfortunately last time, so I'll have to update. Um, it still has good stuff in it, but it's not. It has a lot of more basic stuff than what we did. Uh, but if you look in here, I have a. This is a basic template. I took this from an earlier course because for a while, we were pushing using LaTeX in the earlier ones. For those who didn't, I included a brief LaTeX tutorial here. Uh, and there are some Q&As. If you look over, the LaTeX tutorial was done by John Miller. He was uh, one of our teachers here, and I taught LaTeX. And because it's once you get used to LaTeX, you'll be like, why did they teach me this? The whole point of LaTeX is to automate stuff. It's basically a programming language to generate documents. So it was the tech, the underlying engine underneath it was done by Donald Knuth uh, back in the 80s. Donald Knuth is the guy who invented algorithms as a computer science idea. He's the only living computer science theoretician. I consider being all-around brilliant guy and a really nice Christian too. So just a lot of great stuff about him. It's also the only program that we know of at this point with over 1 million people use it, that there have been no errors found in the last 20 years. It is believed to be completely clean code and also have every feature, if we can think of a feature it is missing. So they believe the development. Now, people will stuff just because they want to change things around, but there are ways to do it like that. So this one breaks every paradigm in computer science. So it's kind of a cool thing in and of itself uh, to be used to. Now, the neat thing, you know, on this, the idea is you don't want to keep repeating things over. You want to automate tasks. So for instance, like we have, if you do this before, you copy your word and paste it in, and then it goes through and edits, changes everything so that it's readable and you have to fix it. Then you discover there's an error in your code and you're like, you know, these not nice thoughts in your head. And you're, did I repaste this, change this, how to fix it? This is a neat thing with, LaTeX. For instance, there is a package for programming. And you tell it what language you're dealing with, and it knows the syntax of the language, and you tell it where the file is. And every time you run it, it'll re-import the code and types it. Knows what the language is, you make it bold, the keywords, or whatever other stuff you want. It knows your language for you. You change the external file, just run it again. It'll re-import the stuff and correctly typeset it. Or things like when you get on to do your dissertation, if you go on to grad school, thesis, if you're doing masters, so that sort. It will automatically generate table of contents. It will automatically generate your bibliography for you and typeset it correctly. It does all kinds of stuff. Rather than cutting and pasting your images in, tell it where the image file is, it'll pull it in according to the function. Tell it and typeset it correctly. It's the actually only good way we know of actually typesetting equations, for instance. So it has the standard syntax for this. It's so much better that even Word has to adopt text stuff. So if you go into Word's equation editor, you can type the math stuff and it will actually correctly typeset it. Because they tried for several decades to do other stuff, and in the end, they had to use LaTeX to get stuff right. And this has been right since the 80s. It was also the first open source code project that was out there. Um, Before open source was a thing, this was the first one that was open source, followed in 5 years, taking a lot of the ideas that were coming in. Okay. So there's just so many cool things about this that makes it. Like, and the nice thing with the image, again, you change the image, it'll automatically update, import, fun stuff like that. So, you know, you'll see this is the comment they always make, so he picked it up too. Right? It's a, people say LaTeX, right? It's not latex, right? It's not, it's not English X, it's not TEX at the end. It's tau epsilon chi. It's Greek. And the point of it was he was trying to show it's the first one that could typeset other languages correctly. Right? Built within the text structure and the extended thing is every language any human being has ever spoken. It's got the rules for them. Even languages we don't know how to speak now. It's got all the symbols for linear B, for instance. You can actually tell it to typeset stuff in if you want, right? So you can literally do whatever. And I'm using those are kind of extreme examples. So you can do there any language you want in the world that's spoken today. There is, they've got a package called Babel. It will let you typeset in whatever language you want to. It does correct. characters and things like that. Right? So it really is designed to make your life easy and be completely extensible. Right? On your side, it's really nice. You know, this font against it is not a WYSIWYG. What you see is what you get. Not that at all. It is a tagged language, right? HTML again borrowed a huge amount of stuff from LaTeX when it's first came out. So yeah, it you give it command like you tell it this is a section and things of that sort. You're welcome to read through this. It gives you ways you could do things. Um, you know, so that's kind of this is just a typesetting example. It shows you little tables. I do actually find it also particularly clean. Once you get used to it, you'll be able to recognize it. When Knuth made this, he actually made his own font to go with it. And he studied how fonts were done and what makes them more readable to human beings. And so he created a clean one. It's called Computer Model, right? But that goes on, and you'll start to recognize. So you can use whatever language you want, but or whatever fonts you want, but its own built-in one is particularly nice. So underneath, so this is John Miller kind of wrote this one out. So I'll walk you through, right? Percent is a comment character. So those just, they get a, right? So it's kind of nice having a comment character. Anything after on the line, it doesn't carry to subsequent lines. You could see these backslashes on here. That starts commands, right? This is the one that starts it out. Document class, use an 11-point font, typeset as an article, right? Use package is their load library command, basically. So it's telling you to load. Remember I told you there's all these lovely little things. This is page margins, so you could set the page margins and, you know, tables and importing graphics of different types, so on and so forth. Paragraph fill and things of that sort. So there's all kinds of little libraries that are in here. One of which is the listings package and the colors package. So this is one that I kind of made a big deal about wanting in here because this one allows, for instance, these are some defined colors from this color package, but right here, this is basic Verilog definition. Fine. So setting for Verilog stuff, the language is Verilog, so you have to tell it, right? I define a style I'm calling Verilog here. He just took this one for me, right? Typeset, give it a light gray background and some blue rulers on the top and bottom. You can put in other places if you want, but makes a blue line top bottom. There's also LR for left and right. It sets it to the column width. It sets, use one of these basic text fonts. Looks a little more code-like. It will break lines and things like that. Um, Sets up its tab sizes and everything. And then we made a command to help you do it, right? So when you're typing, we made a brand new, this is another nice thing about programming language, command. So we made a command Verilog here. And this command Verilog takes two inputs that are in here, and right above it in the comment, it says what it is. If there's any particular options you would like to do it, right? And then what is the file? The options are a choice you can make. Do you want to include it or not, right? But you have to give it a file name. So, this way, if you want something other than just Verilog, you can add more options to it. But it is an optional parameter. So square brackets are optional parameters. Curly brackets are required parameters. So that's the file name. So you just tell where it is. That should be a complete path unless it's in your same directory. So you can put it anywhere. And that's where it's going to go look for this. And then it knows according to this, the language and everything else and what you want to do it. So it will typeset it. That's all the header stuff. So remember when you're doing HTML or something, there's a header and body. That breakup comes from here. Right? This document, this is the body. to find a title, you put your name here, literally put your name there, tell it to make a title, it'll build it for you. And then this is kind of a standard setup. Summarize what you were supposed to do. Here you would be specifying the fact that you were doing this left shift, circular barrel shifter, right, and things of the sort. The only question I'm asking you here, I just want to change it from Q&A. And earlier, like lower level classes, they ask you to answer these questions, what's this, what's that, right? At this level, I think that's kind of trivial for most of you. So what I'm asking you to do is just actually describe the methodology. Teach me what you were doing, what you were doing. Describe that, right? So you'll get through and instead of Q&A, you just give me your ideas. So the first one's really short, a paragraph, describe what you were doing, not really about shift circle, barrel shifter, right? In the Q&A, it's called method, right? So just change that, and then describe it, right? What were you supposed to be building? How did you approach this? That's kind of your overview. The results section, you should describe how it's going to be testing, and test it this way, and these outputs. Here's a snapshot of the screen showing the outputs configured with this, that type of thing. Just walk me through. Right? And then you need the code area. I basically want you to include your code, and I showed you how to link it. I just want the the design and testing. You just give me those ones. It should only be a few. That will get included here. This is for readability. I also want the original files for the code because I want to be able to. So, but effectively, that's all it is here, right? You could just come in and you would, where it's an area, you just go for and type. A blank line makes a new. So, otherwise, white space doesn't matter. Doesn't matter how long the lines are, that one word, and if you really want to bunch it together into a pair. A blank line that's starting. Otherwise, it's pretty simple. Right? You want to include in the code thing your reference to code, and I don't know if he stuck it in here or he did not. All you have to do is come in and grab um, this one right here, copy it, paste it down. You can delete the listing options part because you probably don't know what to do with it at this point. That's for just if you want to change something, and just put the file name. Fine, if you have it. So it should work also. If you have any questions, you know, yeah.
So would that line go in the curly bracket this code or underneath it?
So let's just grab this copy. Um, Actually, let me just download this whole thing. It'll probably be faster because I'm not sure which tool they use on this. So once you have this, I'm just going to leave it in downloads because I don't care. Text Studio is perfectly fine. So it should come up for you. The blazing speed. Yep, yep, yep. So while we're waiting, um, that's there's this basic area up here is going to be your where the tech files are themselves, right? This gives you, it kind of breaks down inside. It discovers what that area, right? Section, summary, section, Q&A. It kind of reads through the file and gives you the structure of what your document is. And this is where all your messages and everything compiled are. So for instance, and you see it typesets since it knows what the language means. Um, it goes here. So I could come down and put my name in here. Wait. I'm and in here I could do stuff like, you should give a couple more words, but I could say something like barrel shift left circle. Obviously you'd want to make a sentence, right? I could change this from Q&A to methods. Notice this backslash before ampersand. Ampersand is a special character. So some characters are defined as special. This is the tapping section. When you make a table, this is the one that kind of tells you to go to the next cell. So it uses ampersand for something else. So if you actually want an ampersand, you have to give it that backslash. And backslash ampersand goes, oh, you don't want to use it as this, you actually want it ampersand. So there's a command defined as backslash ampersand that prints an ampersand. But I got a lot of shortcuts. There's tons of stuff on this. I could, for instance, just put in here method. And notice how it changes it over here under the section. It goes, oh, you want something called method. Um, Now, I could come in and grab here's my how to use. I technically don't need listing options here. Like I said, it's an optional thing. Uh, I should download a LaTeX file. Give me a sec to find, there we go. Do I have a sample LaTeX file here? Oh, sorry, a sample. Um, oh, I should actually have, we typed one yesterday from pass through. Let me find that pass through file. Okay, where did I put it? Oh, through. Okay, sources. This is, like I said, they make this horrible structure for us. I'm just going to copy this and paste it back into my downloads. In some sense, this is the backwards of what I probably should be doing, but that's life. I should be moving things to documents, but this is just a quick and dirty, and I want it in the same directory so I don't have to give it a path structure. So I just give it the file name because I stuck it in the same directory. I can then save this, and you should be able, there's the build and view, probably easiest here. So it should go through and do the LaTeX. And obviously I didn't change the lab number. It's set to blank here. But if you notice, it's imported my code. I just got summary method and import the code, and it's nice and upset. Then sure, whatever it helps when it goes from one page that started here. So that's, but you notice it's blindingly simple to do this, right, for the basics. Just literally just copy them, put your file names, and the other stuff just type text. If you want to include math notation in there, I guess I should show you that quickly too. Um, maybe under the methods, I want to include um, some math to say 2 to the I or something like that. If you want to do it inline with text, you know, for example, text type exponents are the, and I can just do an open dollar sign. Dollar sign tells you math mode. So it's going to do an inline equation, and I could say something like x equals 2. The caret means exponent, so I could say like 2 to the I, you know, for instance. And if I then, put a period after it, I can also do all kinds of other stuff if I want. Simplest one, again, if I want a standalone math equation kind of typed up, um, I can do something, you know, um, whatever, y is equal to, I don't know, whatever you want, 3x underscore Shabbat. So this makes a little I in the bottom, x little I, right? Um, Squared. I don't care. You could add as much other stuff as you wanted, you know. Uh, Plus, maybe I'll put a 2 slash cosine. And you'll notice it gives you some hints. There's cosine, hyperbolic cosine, whatever. Um, and, Theta. Right? So just telling it Greek stuff, whatever. All right, so I just type out some useless equation just to demonstrate, oh, look, useless equation. I do not show this again. That's really annoying. And there you go. Here are my equations. My x equals 2 to the I. I can tell it if I don't want to break or not. And you can see there's my silly equation I just made up. And it typesets it all nice and easy and clean. It's very easy to read. It's very So that's basically in whatever 15 minutes, 20 minutes. Yes, you have to put in. So, like all programming languages in the universe, the first thing you have to do is call them. If you want more, it goes to these now, put in curly brackets. So if I had wanted something larger, like 2 to the I plus 1, right? Uh, and unfortunately, it's trying to help me by giving me the ending thing. Uh, So the first one is going to be up in the exponents, and then, whatever, I'll put a plus 5. So you'll see after the curly brackets, it doesn't include it. And so now you see it included it in the curly. It's interesting for you. Um, if I want to put something in a fractional thing, um, you know, whatever, I could say slash frac for a fraction, and it tells you numerator, denominator. So I could say, 5 over whatever, you know, s plus, maybe eta. We'll put a Greek letter in for some unknown reason just to demonstrate Greek letters. Uh, it should auto save when I click to run. So, and you'll see it does, and it understands the difference between if you're doing it in line text, it'll try to adjust the spacing between the lines for you, all kinds of stuff like that. Um, you can see it's pretty easy to stick any crazy. It has all the math rules. The initial technique actually paid to new to, kind of be founded computer science at Stanford, and literally the guy who started up the idea of how you do algorithms in computers. Um, so, he figured out what he felt was the best way to do it to create this. If you're interested, there's also a variant he proposed that's called CWeb. So if you run it through a C compiler, you get the code, and if you run it through tech, you'll get the documentation. So he added so you fuse your code with your documents in the different language areas. So they've got things to specify which one's which. So that way, your comments are not just random comments. Your comments are actually designed to generate, the documentation. So you're not doing separate things. It's trying to increase compliance of making decent. It's not just stupid random people. Anyway, um, so just some different interesting stuff. There's all kinds of neat stuff that we could do on this. Does this make sense? Feel at least a little bit comfortable with the ideas. Try, you'll run into something that's weird, you know, there's a ton of documentation. Shoot, pretty soon you'll learn it. I had to learn this when I did my PhD at Stanford. Advisor told me, you will not get a PhD in the UC system. Okay. Um, And after doing, like the first few times I did, oh my gosh, I have to do all this work to tell it how to generate it. And then after I discovered, oh my gosh, I don't spend any time, you don't worry about how it's going to be. You just tell it the content. And once I got freed from that adjust the font and try to make it look exciting and whatever, um, it just freed me to just think about the contents I was doing. And once I did this, I don't do like it bothers me deeply. It makes me do something. Right? Because it's now much slower. Because now that I don't worry about all the stupid stuff, I can generate things very, very fast. So if you notice, for instance, the style this does it is going to be what generates the syllabus that you get. Like I didn't actually generate a table or it has a schedule. I didn't actually write that schedule. I tell it the sequence of topics and what chapters it relates to. And I wrote a program to figure out the date, first date of class. Right? And they have a separate little thing that's a data structure that tracks holidays. And it goes through each one and says, is it a holiday? Next topic. And it puts the date and everything. So it puts the line rates at the end of the week and all that kind of stuff. That way I can just move titles around and don't have to worry about calendar and it's just stuff like this, right? That's like if you've ever had to put a schedule out and make a calendar or something, it's annoying at the shift. Remember the date shifts, date and stuff. So right? Anytime you can automate things as an engineer, it's longer if you're doing it all the time, it's gonna save you time. And unfortunately, most things we do, you have to do most times. So that's what I'm trying to push this to get you that initial so you see how to do it. This is not the only one, but for instance, if you learn this in like MATLAB, for instance, also when you generate figures, that you can, besides just putting simple labels on your figures, if you want to have fancier stuff and have words and Greek letters, symbols, and equations, MATLAB uses LaTeX. It's it is standard notation if you're talking frame by inch. IEEE prefers LaTeX for the documents to the journals because if not, they convert it to you. So if you send them Word and they from those things, but they literally have somebody who copies your Word out and puts it into LaTeX because all of their transactions and journals are typeset because it just makes it consistent. So it's just easier when you do those things. All right, we good? Awesome. And this shows you how to do it. When it pulls that up, it's just a PDF file that it generates. So when you look in here, you will get the PDF. So once you have generated that, notice it's now there. So you can just give me the PDF and then also the system there just upload. So and you can latex upload to latex or it will generate a variety of different formats, but it's actually a different type of thought. It's science. Yeah, it's not just that it's Microsoft, but it's the difference in WYSIWYG. So most WYSIWYG ones do not use actually these kind of inline commands like this where it says action and everything else. What it does is it has a separate form called resource form. And when you highlight the text, right, and then tell this in the resource form, right, it takes that chunk of text and makes it link into the resource form, right? And this is why it's sometimes hard to undo stuff and stuff and you bring those things, because what it does is it's actually putting these in another form of the text. So that's what you ever can program. If you load a program into Word and then you save it, it can never be done again. Because Word makes this stupid extra data book that's in there that has information on typeset the thing. And it's not just getting at this underlying thing. It's a fundamentally different way to specify how you should make it. And that particular way is nice for WYSIWYG, if you're highlighting the mouse and stuff, if you're things. But unfortunately, you ever notice it easily and it gets little broken things. At that point, the only thing you can do is start it again, right? Because it just messed it up so bad that you can't find anywhere and confused. That's because that linkage between where the text form and the resource form where these tags exist in is not cleanly maintained anymore. You know, they're no longer nested and stuff. It's really easy. Okay? That book is just dead. So that will never because the stuff is right there. Right? You know, if you mess it up, it'll just tell you how to type it. So it's not perfectly one to one exactly how you go. So rather than create something that, so there are some people who got tagged to work and work to tag converters. It's good tag. It'll give you better word than Word to tech will because Word's not trying to keep anything clean. You know, if you've ever taken a look and they try to do this thing with an open format or something, you ever know it's just how ugly it is. If you look at it, it'll do that to you. So whenever I have to do it, I just literally open the Word file, copy the text manual, and stick it in, and do all my formatting. I just don't trust it. If you just what PDFs do too, PDFs do it's never copy PDF because the date thing they put these non-working characters that are not visible to you because space differences and things, which is nice for spacing. But now you have an invisible character inside your code area that you literally can't find, but that when it goes to compile it, they're completely visible to the compiler. So it doesn't know what's going on. You get these weird errors. And something like the red line because it generated an error 5 lines. You know? So it becomes horrific. So my general rule is don't trust computers. You can do what you want. Okay. So part of the diversion on that, hopefully we'll get that. We're going to quickly create a project here, which I'm going to make for our barrel shifter. I am again doing the right shift circulant because I don't want to do your problem. I do not want to specify sources at this time. Otherwise, we're just doing RTLs. I asked them if they would do this. I don't know if they've gotten around to it yet. Um, so we want, so it's not the vertex. I do not see all the boards installed. I forget which board we were, or which one of these chips we had last time. Um, X, it wasn't XC7, CSG. Oh, I didn't bring the board thing down with me. CSG. So that specifies the ball grid away on the bottom. I think it was a 2. I don't remember the size of it. Nope. Well, I don't remember, so I'm just grabbing one randomly. I can always edit.
C, A, 1, 2, 2.
Go. C7A 100. Let me see. So is it one of these you see? Okay. So T what?
TTG, TTS, G,
It's this one. Okay. If you ever get it wrong, you have to just go back in and edit that three of your. Okay. Sources. I'm just going to create a design source. We're going to technically. Oops. Don't yet. I'm going to make two different ones. One of them is going to be our BS barrel shifter, right circulant. And I'm going to create a second one, which will be my tip level one. So this will be whatever, the board interface. So you got to give it some name. We're going to, I think a barrel shifter, but it's going to have to get switches to do hands all that type of stuff for me. I only know those two. We'll make a simulation separately. Okay, for the board interface, I'm gonna need. Um, let's see, it's CLK 100 megahertz, I believe. I need SW, which is a bus, and there's 15 to 0 of them. And then I want BTN. I'm going to do button up. That's on your 5 button thing. There's a left, right, up, down, center. So I'm going to pick up to say import the number, and I'm going to have a, let's see, BTN. I'll do right since I'm doing a right shift to specify the shift. Those are just single buttons. Um, and I will need my LEDs as an output. Now, again, why am I doing this? Why won't you have, 16 switches and then there's 16 LEDs? So I need to be able to specify the 16 bits for the original thing. I need to be able to specify log 8, 16, to say how much of a shift, how much am I going to shift this 16-bit thing? Right? So I need a number. That's more than my switches. So what I'm going to do is set my next push button up. That's the number you want to shift. Then I'll set whatever, how much do I want to shift it, and then I'll push button. And then specify how much of a shift I want to do on that. We just don't have enough switches, so I have to double use. That's what the buttons let me do, specify which one. Then I can change the number, or I can change the shift at any point by just using two buttons. That's why I'm adding a button. and the LEDs will just show the shift. Does this make sense? So that is my board interface. To also add this one for the this one we had parameters, but I'll add those later. Um, so I needed an input, which I called in, I believe, and I believe I had. I have to remember these. So shift, mount, and I think I just called it out. Is that right? These are all going to be buses. Now, since I want these parameterized, it's going to look weird, but I'm just going to make them all one. I'll show you why in a sec, because when I change the parameter, it's always going to be whatever that number is minus one. So putting a one there just makes it easier for me to change it later. So I specified them. They should both now be in my design constraints. Uh, So you can see it's added these. I'm going to now have to tell it I want to parameterize this. So I just click after here and I go hashtag, right? And then we had, and I think we called it N, is that correct? Oh, it's supposed to be an output. I can change that. So I clearly missed one. And I think we called it log2n. Is that the other one? Capitalization matters. Okay. So now I've got my parameters in here. So I wanted in should be n minus 1, and out should also be that. That should be an output. See why I was saying it's kind of easier if I just made it 1 there? Because I don't have to change the number. And I think this one was log 2, Ben, if I don't. So now we've got all of our, oops, capitalization matters. I did not. So now it's not mad at me. Okay. I also wanted all these to be logics. In this case, it wouldn't actually hurt me, but it's a good habit to get in. All right. And then we had to define our A, if I remember, logic. And we needed the number of bits, so that was n minus 1 times 0. That's what we called A. And then on the unpack side, we had log 2n. And so remember, this one's not minus 1 because we needed 1 extra. Uh, and then we had to assign the two ends of A to something. So the output gets A0. And remember, when we do this, it automatically is going to pick the unpacked one and take A as this data type. So we get n minus 1, or n of them, I should say, n minus 1 to 0 automatically. And on the input side, I have to make sure I specify this one, log, and so this should be whatever we had before, equals n. So the whole purpose of this is just hook A up to those. And then after this, we just had to do our generate statement. So we need a gen var, right? So I made gen var I, And we got our for loop. You do not have to wait for me to type since you already have this. We built this all. Let's see, it's I less than to n I plus plus Tumblr. And now what do we want to build each time? So assign AI to be equal to chant I question. Now we have our roundabout curly bracket. Now I have to start remembering. It was AI plus one. It's the earlier one. Okay. And let's see, it was 2, the I minus 1 down to 0, which should be on the right-hand side. And then the left-hand side goes to the right. So that should be A, I minus 1. And then this will be N minus 1 down to 2 to the I. Fine. So that's if I'm trying to shift it, that's the shift definition. Otherwise, it just gets AI plus 1. So I believe that's what it is. You should double check me. And annoying as they are, they don't properly back these back out for me. Did I? Did I? ENDMOD. ENDMODULE. Oh, is that what you're reading? It should be just what we typed last time. Let me see if I can change the font on this dumb thing. Oh, anybody remember the keyboard shortcut like Command Plus or something? Okay, too much. That does a Freddy job. Wow. Boy, Windows, you stink. Oh, that just pulls up the. There's a way to change the font, I thought. You. Well, if anybody gets a quick thing on how to make the font bigger, I have no problem. Oop, there already was an end module. Okay, need 2 of them. Okay. Um, anyway, this is exactly what we had done last time, so hopefully it'll clean up. Or maybe uh, take a quick look to see if I can find a way to make the font bigger. I do not obviously know. Um, but anyway, I'm going to stick with this. If anybody figures one out to make it increase font, if you can see where they put it. I never mess with the font, so that's not one of my. part of my skill set. Okay, so we now want to come in here for the board interface. We need to push a button, sort stuff. So I'm gonna have to create tools, options, settings, maybe text editor fonts. I don't see fonts right. Now let me know when Hello World is good for you. That's good. Is that easier to read? So thank you. Oh, I try to squeeze this as much as possible because this is big now, so I need as much room as I can get. Okay. Anyway, does anybody help you specify the football? Because now I have to do it. So I need the always underscore football, FL. Yeah. And as you start typing, I'll see that for you. Remember with these, I'm going to need to tell it, right, an at sign to let it know how am I triggering this. I'm going to trigger this off the clock. And I hit that name, so I'm just going to copy and paste it. Actually, I hit it enough. I'm going to make, I think clock is much easier to read. Okay. Now I need two different flip-flops. I'm really lazy, so I'm going to stick them all in the same thing. Okay. Now, for a flip-flop, remember, no syntax is, don't show this. So remember that trying to remember, reach back will just help you increase your memory. So since we're specifying a time, we'll go on that non-blocking assignment. We have to be able to specify the input is going to get assigned whatever's on the input. This is. That's how it's going to be defined. So we're going to get two different kind of variables. One of which I'm going to call one, say number. That's going to be whatever we're storing. And then I like just using an N before the same name. I'm going to make that my input. So I have to define two. So for me, every time you see N and then a variable name, it's going to be that's the next version of the input that's coming in, and the main name, whatever. And it's unhappy at me because I haven't defined these yet. And then we need shift amount is going to get next shift amount. And it's going to hate me for this too for a sec because it's going to be like, what are you doing to me? Okay. So I'm going to come up to the top because I like sticking all my things at the top. You don't have to put them at the top, but I just like this. So logic. And remember, I'm going to need, in this particular case, I know exactly what my n is. So I'm just going to actually put that in. Right, so it'll be 15 to 0 of, and I'll need number, and I'll need next number. And the second I've defined that, notice the top line got cleaned up. And then logic, and this should be 4 to 0. Right? Or it's actually, no, it's 3 to 0. Because that gives me my 4 bits, right? 1, 2, 4, 8. Okay. So 4 bits, and this is shamped and next shamped. And now it's like, oh, okay, I like this. So I've told it that it's going to store these, but then I have to tell it how to get these. So now I'm going to remember there's always, this does the storage, then I have to tell it how to generate its next state. So that's a combinational. So I take always comb, and we'll do a next, right? Now, this is a convention I like to follow. So I'm going to recommend it to you. I'm going to, right at the beginning, define it. I can change it within this, and it all happens at the same instant, one after another, but it doesn't advance the clock any. So it just shows a sequence, but no time advancement. And this kind of sets the default. Where what I'm basically saying is, it's whatever your output was. Hold it. So I'm just feeding those back. As the default, it holds. Now I'm going to specify after this what to do as a special case. This way I never need else statements. So remember I told you I always need the else's? Well, technically I was not telling you the whole truth. You always need to be able to determine what's in the else. One way to do that is just specify all of the hold conditions, and then if you just specify what's different from hold, it still becomes unique.
Just like, this code is always already it.
No, always code means take a look at anything on the right hand side that makes the right hand side or changes, run it again. It's combinational, there's no in. So it's just anything on the right hand side. Anything happens. It rerun it again. Make sense? Okay. So now all I have to do, remember I just made those buttons. So if BT and up, the button up was one of my button conditions, and that one was going to change my number. So next number equals switch in this case. And actually I don't need an end because I don't need a begin. It's a one-line thing. And then I can just say if button right. Again, it's a 0 or 1, so I can use it as a condition, and that means next shan't equals switch. Now notice, next shan't is smaller than switch. So what it's going to do is it'll take, first starting right, the first, if I don't specify, then I'll still get through. So I could actually say 3 to 0 switch, but it doesn't do any different, and this is more readable. So I'm going to be lazy and all at the same time. Notice no else's because it can get the else information from you. So it's uniquely handled. This becomes awesome when only one of these changes. Technically, you need to be able to specify both. So putting the defaults right at the beginning makes it easier to avoid forgetting something. So it's actually better than an else because technically in every else you have to exhaustively list all possibilities. Right? And do that. So just easier to specify all defaults and then say whatever's different. Okay, we good? Yay. All right. Then all I have to do, I now need to make a version of this. So I'm going to instantiate it. I copy this because I don't want to remember it. and I paste it in. In our case, we want n to be 16. And I want it to do the calculation, so I just remove the rest of that. So I'm going to call this my BSRC. I've got to give it a name. Remember, the name is after you specify the type. Opt. And in will take number. Shamt will take shamt. And I didn't do anything changing where my output goes, so I'm just going to pass that right to LED. Right. Now at this time, what was it complaining for? Oh, because I'm not supposed to, this is a parentheses. Okay. Remember, whenever you do this, it's dot, what is the internal name, and then parentheses, what you want to pass to. Same inside here as it is out here. All right, we good? So you should be able to take this at this moment. Now that we've added this, once I save it, if you notice over here, right, it has them separate, and the first one I built is considered the top level. That's what these little 3 dots mean here. Right? The second this is not saved, that's what the star means. The second I actually come in and save this, actually let me just use the button. It should update this and then go, oh, this one was actually the top one. So it made that the top level module and it dropped the other one. So it should automatically figure it out. If I add the constraints file in, you can now build this. That we've already done. I told you I wasn't going to do that again. It's all up to you. I have used, I believe, the correct names from it. What we want to do now is actually do a simulation. So we're going to do a simulation source. And I'm going to create a new file in System Verilog. There's a bunch of conventions. You could do the top level module underscore T. You could do T underscore first module, or you could write T out as test. I'm going to do mine as test underscore, whatever that top level module was, which in this case is board underscore interface. And we'll finish. I don't want any inputs. This is a test. So yes, I really want to do this. For some reason, they like not giving us a good interface thing here. We do not need any of this junk. A test thing doesn't take anything from the outside. It's faking the outside world. So I'm going to make an instance of this, but that means I'm going to have to create all these little variables. So easiest way to do it is just maintain the same name. So I'm just going to paste that and make identical names to all of these. And as logics, that makes my life much easier. I shouldn't. I pasted the wrong module. Oh, bad me. Um, Excuse me for 1 sec. I want to actually do board interface. And I didn't give any of these names. Okay, so because I'm going to use the exact same name. Anybody know why? It is easy to read. It also gives me one other big advantage. It is, because I can just use that dot star syntax. And I'll paste that a second time. Now I can actually build my board interface. I don't need any of this work here. I can just tell it dot star. I just have to give it a name. Um, and you should make your name either device under test, DUT, or unit under test, UUT. I don't care which one you pick. Either one is fine with me, but you should pick one or the other. There are sometimes a bunch of modules you might instantiate here, and we don't want to try to remember which one is the one you're actually testing. So if you use, these are industry standard names. So if you use these names, pretty much anybody will be able to read your code. So, anyway, that gives you those, right? Now, for all of these, I then need to set some things up. This will never be built, so we don't actually have to use these flip flops or anything else. I will deliberately not use those because I want to make it clear this is not synthesis, it's only simulation. So I will, if I put in always, I will only put in always. I won't put the actual. So in this case, we have one and only to build. Right? All things, I say at star, which means any event that goes on. I begin end, so it recognizes this. And then I'm going to just say to wait 5 minutes. It's going to be a clock of 10. And I will say clock 100 megahertz equals not clock of 100 megahertz. Now, this just means it'll flip every 5 time units. My time units are 1 nanosecond. Right, so to go through a full cycle will take 2 of those to get back. That means every 10 nanoseconds. 10 nanoseconds is a 100 megahertz clock. So by doing this, I have actually built the exact clock it is asking for. Now, this, at some point, I have to tell it starts off as 0. Right? Otherwise, it will be flipping, you never told me, which means you didn't tell me, I don't know. So you'll get all X's from this, unless you put in an initial. Remember, initials just start at the beginning and run, and this is going to be, I'm just going to call this setup. Remember that colon just means give it a name. All right, so I initially want clock 100 megahertz to equal 0. And I can set defaults for all my other things too. All right, switch, button, stuff like that. Okay. So switch equals 0 and button up equals, this is going to look weird, but I'm going to make them ones. I'll explain why in a sec. Button right equals. So that would be a very good reason, right? That's what we do this because the first thing we want to do is to actually depress the button, the turn it on, the turn to, you know, so it's easier doing negative. I started at one that's just easier. Yeah, I don't care. You can turn it when you want. Figure out how you set this to determine it. If it's starting at 1 and it'll just automatically read these things in. Actually, pass our time. The only thing to do then is give a sequence of events you want it to do. And I can do that as initial, where you'll go in and you say, how do you push the button? So I want the switches to be awesome. And you basically just say, what is going to be, they set the switch to this value, they push a button, right? Whatever. Um, Again, the nice thing on this is remember when the button is 1, right? It'll read in the value of switches. That means it'll immediately read those in, right? So it'll keep there when you push time. So you should, otherwise remember it's okay. All right, we good? So you should be able to finish these and get some response from this. Let me know if you have problems.